Hello, let's discuss on the topic regulation of kidney function. The first regulation will be renin-angiotensin-aldosterone system, also called as RAAS. When the body loses sodium ions, it also loses water to a great extent, and this results in the fall of blood pressure. So this fall in the blood pressure is being detected by the juxtaglomerular apparatus that is situated just below the Bowman capsule. Now once blood pressure fall in the blood pressure is being detected by this apparatus, the juxtaglomerular cell begin to release the enzyme called as the renin into the bloodstream. So this renin production result in the activations of the protein called as the angiotensinogen 2A peptide angiotensin 2. So once this angiotensin 2 is produced, it results in the gradual rise in the blood pressure, and even the glomerular filtrate rate has been increased. Angiotensin 2 increases the blood pressure by causing the arterioles of the blood to constrict, and it also releases a hormone called as the aldosterone hormone. So once this aldosterone hormone is being produced, this hormone stimulates the reabsorption of sodium ions and water by acting on the distal convoluted tubules of the loop of Henle. So this increases the blood volume and the blood pressure, completing the feedback circuits. The second regulation is the role of atrial natriuretic factor. When the blood pressure increases to a great extent, there is a production of one hormone called as the atrial natriuretic factor. So these hormones opposes the increases in the blood pressure. That means it opposes the functions of the renin-angiotensin-aldosterone system. So when this atrial natriuretic factor is being produced, it inhibits the release of an enzyme called as the renin from the juxtaglomerular apparatus, and also reduces the release of the aldosterone hormones from the adrenal gland, and this leads to the less absorption of the sodium chloride from the distal convoluted tubules, thereby bringing down the blood volume and the blood pressure too. Now let's discuss on the mechanism of the concentration of filtrates. Mammals have the ability to produce a concentrated urine, and the loop of Henle and the vasa recta plays an important role in the concentration of the filtrates, that is urine. If we look at the loop of Henle, we see two types of limbs, the descending limbs and the ascending limbs. So the flow of the filtrate in these two limbs, that is in the ascending and the descending limbs, are also in opposite direction. If the filtrate in the descending limb is flowing downwards, then the flow of filtrate in the ascending limb will be in upward again. So there is the movement of filtrate in this ascending and descending limb is in opposite direction. The flow of blood in the two limbs of the vasa recta, that is this vasa recta is formed by the efferent arteriole. So this flow of the filtrates in this vasa recta is also opposite, that is in the counter current patterns. Now the region between the loop of Henle and the vasa recta, and even the counter current pattern in them help in maintaining the increasing osmolarity towards the inner medulla of the kidney. As a result, the blood entering the renal medulla in the descending limb comes in close contact with the outgoing blood in the descending limb of the loop of Henle. This gradient is caused mainly by the flow of sodium chloride and the urea. Sodium chloride is transported by the loop of Henle. In exchange, the flow of sodium chloride in the loop of Henle is exchanged with the descending limb of the vasa recta. Similarly, the small amount of urea entering the thin segment of the ascending limb of the loop of Henle is transported back to the collecting tubules. So this shows that the transport across the descending limb and the ascending limb of the loop of Henle and the vasa recta is in opposite direction, and this special arrangement is called as the countercurrent mechanism, and this helps in maintaining the concentration gradient in the medulla region of the cortex of the kidney. So this is all about the mechanism of concentration of filtrate.